I've got background noise, Peyton.
All right, give me.
There we go. Welcome everybody to KR's Lunch and Learn, May 1st. Welcome to May. Appreciate you all coming. I think things are looking good. We're going to continue these. Peyton and I are talking with Stuart down in our Portland office. I think we're going to continue these through the month of May. That's our plan. We're thinking of other topics. We're getting good suggestions. We have a ground penetrating radar. We might consider that. We have further, one thing I know we want to address is MS60 and processing the scan data in Infinity. We're going to address that, and then other topics as they come along. We have Peyton Hatch he's, I believe, in California, but he's out of our Salt Lake City office. I'm Rob Mitchell out of our Montlake Terrace, Seattle office, and Stuart Snyder is down in our Portland office. And Josh Weiwei is up in our Montlake Terrace, Seattle office as well. He's joining us today. So appreciate, we got a lot to cover. A few items again. I keep adding to, I've added some, made little changes, added to our Dropbox folder. At the end of this, either Monday or roughly by Monday, I'll send an email to everyone that was invited and with the Dropbox location. If you can't get in, just send me an email and I'll get you permissions or access to the Dropbox. And it contains the material, training material for Captivate field software, Infinity Office software, the HDS software. We're adding a folder for HDS, high definition scanning software, and training materials or links to training materials, as well as some versions of the field software, some versions of the Infinity, the latest versions that you can download from the Dropbox. So it's a growing, flexible, living Dropbox with training materials. The big central location is a Word document that has direct links to training materials. I highly recommend just taking a look at that. You'll see as we add to it additional links. Leica has, since February, added a bunch of YouTube training videos on Infinity as well as Captivate that are really good, and those links are accessible through that Word document. So I want to mention that. I want to keep mentioning that because I just had another conversation with another new person with Captivate and sent him the links with information. And as I talked, I realized there is a lot of material out there, but just the intent, one of the intents of these webinars is just to guide you, give you a little bit of direction to where all this material is, and maybe focus on what your application for that, what your work you're doing. The other thing is we're all open, we're fully going in all our offices starting Monday. We are still doing our by appointment only, but we are going full bore on every office: Seattle, Salt Lake, Portland, Fife. It will be manned and there's staff in there. And we are taking orders and shipping and receiving. So with that said, looks like good. Everyone joined on. Got another pretty good group going right now, so that's fantastic. We have usually a Leica person, Tim Kerr, I believe, might be on, and we enjoy having the Leica folks on, and they're the official North American support group that has been joining us for the last 3 or 4. And with that, we didn't want to switch screens, so I don't have anything to show you. I'm just going to leave it for Peyton so he can show you the latest Cyclone software, and I'll let Peyton take it over from here. So thank you, Peyton.
Awesome.
And
you're welcome. Myself. Thank you. All right. So guys, we will we'll go ahead and just get started. Let me close a few things out on my screen. And I'm actually going to turn off my video camera. I am on Wi-Fi. So I am going to turn that off just to kind of save on some bandwidth for this. So there we go. Close this out, and we'll make this big. All right. Well, today's topic is the new Cyclone 3DR. So if you've been a Leica customer for a few years, you're probably familiar with the 3D Reshaper software program. Leica has since migrated that and turned it in, called it Cyclone 3DR. That will be the program moving forward. And I'll show you kind of its new interface today and a couple of the tools. If you're a 3DR user, you'll notice that all the tools they're all still there. Everything got migrated over, so there's not a massive learning curve. And for those of you who are not familiar with 3DR or 3D Reshaper, this is a point cloud software. It's a recreation software, reverse engineering software. It's great for ground extraction, tank inspections. So today, we are going to cover just the tip of the iceberg on what this software is capable of. And I'm hoping that Rob, Stuart, and Josh, you guys can kind of monitor the chat, because I do have that kind of hidden away. So just please chime in if you have any questions. I'm going to skim through a lot of stuff. And guys, please bear with me. I'm going to do a lot of this stuff live. As we all know, with live demos, certain issues can arise. So we'll tackle those as best we can. Hopefully everything goes off without a hitch. So with that, here we go. Okay, so first thing we're going to cover today is drone data. So we're going to be able to, just took a couple snapshots from my screen earlier. Our goal is to be able to take a point cloud from a DJI drone, take it from raw data like this as a point cloud, extract the ground points, and then generate a digital terrain model in hopes that we eliminate most of the spikes. So that's going to be the first thing we cover today. Just after that, we're going to cover an arch, show how you can model out an archway, go from a point cloud with lots of noise and trees to a clean mesh, a smoothed mesh, something you can use for monitoring. A tunnel extraction, so going from point cloud to doing designation of the point cloud via, I guess this is an air vent and pipes, show you how we isolated those, and doing some tank inspections. So got a lot of data to cover for the next hour, and so let's jump right in. Okay, project 1. Okay, so off to your left-hand side inside of 3DR, this is your groups. So I have all the different point clouds. So right now I've imported simply an LAS file. So I create a new project, you go import, and you can drag and drop an LAS file, E57 PTS file. Doesn't really matter what the file is. 3DR is going to most likely accept that file. And it drops right in. And here is our full point cloud. So got a nice roadway. We've got trees, intersection, we've got houses, a ditch that's running along the side of the golf course right here. All right, so I'm going to show you a few really quick tips on how to just kind of clean out some data, like manually. So we can go up here to clean and separate. And I have my tools on how I want to sketch it out. So if I wanted to do like a free drawing, or freehand it, put yourself in pick mode and simply press enter, and that part has been highlighted. I can delete it, I can keep it, or I can split it. So if I say I wanted to isolate that to its own point cloud group, something I could toggle on and off, I'll split it. If I want to straight up delete it, I'll delete it. That's how easy it is to go through here and just do some manual cleaning of the point cloud. I wanted to show that tool. I'm not actually going to delete anything. Let's go back here. All right. So if you've used point clouds in the past and you haven't had ground extraction tools, you know how big of a pain in the butt it is to go in and clean and get the ground. Because if I were to build a surface out of this, of course, this tree is going to get meshed. And I'll have this big arc right here. So obviously with the old tools, I could kind of isolate the area, box it out, delete it. But that would take all day to go in and do this. So, all right, real quick, Rob, can everybody still hear me?
Yeah. Yes.
Okay, good.
Yep.
Okay, excellent.
You sound great. You sound great. So this was flown, just a question while I'm unmuted. So flown, whatever, a 30-minute session with the drone, put into some processing software, maybe Pix4D, and then exported as an LGS, or how was it
This actually was
exported?
done out as an LAS file. So
LAS,
yes,
okay.
this was a, I believe this was some sort of DJI. I don't know what one it was. It was some sort of DJI. Points were put into Pix4D, created an LAS file, and this is what we were left. Okay. All right, so let's use the tools within inside of 3DR, because 3DR does an amazing job of extracting the ground surfaces. So if you select all of the point cloud, you can go up here to clean, and I can do split ground points. It'll bring up the command. There it is. All right, so you select how steep is the ground. Now, I know this is pretty steep right here, but I also know that down here, this is very steep, almost at a 90. And I want to make sure that this detail gets retained when I do this cleaning. So I would actually pull this all the way up. You'll also notice that the Z direction, like which direction are we cleaning the cloud? So I would want to set this as my Z being up. You notice how it changes there? This tool is really handy because you can clean off of different faces, which I'll show you in a minute. But of course, in this regards, I want to clean straight up. Okay. I do want it to create a point cloud. We want it to create a different cloud, essentially like we are going in and we're isolating, or we're layering. So we're gonna have a ground point, we're gonna have noisy points. So I do want it to create a point cloud for the ground. And I want to do it a ground extraction size. Now I want to show a whole lot of detail. So for this one, I did a 1 foot extraction grid. And you can hit preview and it'll go through and show you what you did. And if you didn't like it, you can make adjustments and then hit preview again before you accept anything. I'm not going to do that live because it does take about 5 minutes, but I do have one already created. So what we end up with is it'll essentially do an unclassified point cloud and a ground point cloud. So if I scroll down here, hide the trees, and I go turn off the unclassified point cloud, you notice all the noise goes away. I mean, it's not perfect, but it does a really good job considering it only took 5 minutes to clean all of those out. I mean, it's kind of a drone guy's dream right there to have clean data. Okay, so now that you have your clean cloud, we'll click on the point cloud. We want to create a mesh with this point cloud. So we'll go up to surface modeling and we'll do a digital terrain model. I'm not going to do a standard 3D mesh because I want it to have some intelligence. I want it to go out and find the ground. Now I've already done this with the point cloud, but we can essentially fine tune it by doing it again, by telling it to extract a DTM, and it'll go through and essentially, what's the word I'm looking for? Go through those points and find ground points within the ground shots. All right, so once again, we'll set the slopes all the way up. I'll set my Z direction as up. I don't want it to create a point cloud. Oh, I've already got a ground point cloud. I don't need it to duplicate that, but I do want it to create a mesh using the measured points. I do have local steep slopes. We'll do a 1 foot grid again. And we're going to go ahead and hit create. We'll actually do this one live. And you see for the mesh on an area this big, it's actually humming right along. Okay, just about done here.
Hey, quick question while it's finishing up.
Yep.
The Z, when you picked the Z as up, it was as easy as that, and then it was intelligent enough to recognize what trees were there, or was there any more configuration you had to do other than Z and then clean
No, I
those
simply set Z up because the Z values have all been assigned by the point cloud, so it knows essentially what the flat plane is. By assigning Z up, it's going and doing a ground extraction based off of elevation and looking for a flat plane. It's not simply looking for the lowest point, which I'm going to show you right now. It's looking for what it assumes is a flat plane. And okay, so let's so we have our DTM created. I'm going to go ahead and turn this off real quick. So I'm going to turn on all the points, and I'll show you what I mean by it's kind of looking for a plane versus just the lowest point. Over here, it did a really good job of removing trees, but on these houses, there was no shots underneath it, so I didn't know how to interpret the ground. So even if I go and turn off unclassified points, you notice a lot of these houses are still here because technically those are what it believes to be the ground shots. They are also technically the lowest shots within that area. So that ground extraction is not perfect, but it does a really good job. So I would want to remove those manually if I did not want those in the surface. But yeah, you simply just need to set your Z up. All right, so I'm going to go and turn off my point cloud. And here is my surface that I created. Not bad for a first shot. It looks, I think it looks pretty darn good. Now I got a little spike right here. You got some spikes. If you had brake lines, you could have utilized the line work and done brake lines along the road. But even that right there is really good. But we can refine it some even more. Oh, all right here. So we're going to select the cloud. And I can say, let's eliminate spikes. And you can set the iteration 1, 2, 3. You know how aggressive you want to be. I put it on high, and you just kind of play with these settings so you find the one you like. So I'm going to zoom in on this little area right here. And I'm going to go ahead and just hit preview, and it's going to run through. As you can see, it eliminated the spike. So if you by chance had an erroneous point sticking up, or if you got to remove a street sign or something, the software is gonna go find that for you and get rid of it. I like what it did. I'll go ahead and press OK. I could go take this a step further and I could smooth it because I've got some pretty jagged edges right here along the rocks. So I could grab this point cloud again. We'll smooth the mesh. I want it to keep details. I'm actually going to lower the intensity quite a bit because it's not that bad. And go ahead and hit preview. And there we go. You see it's smoothed out these rocks. I'll go over here to this. Yeah, it's retained that drop quite nicely. Say if I wanted more detail, I probably should have extracted some brake lines along that, but in all honesty, that's good enough for me for now. I've got my trench, and I simply press OK and exit. I have my surface. This can be sent out as an XML into CAD. You can bring in other surfaces. Say you were scanning this multiple times for doing inspections, and within here you could do volume calculations off of surfaces. You can compare surfaces and get heat maps, things I'm not going to do today. Those can be for another webinar. All right, so does anyone have any questions on this before we move on to the cylinders, the tank inspection, and the archway?
Yes, question. When you say it should, if I could have added brake lines, where would those brake lines be created from?
Yeah, absolutely. So under extraction right here, you can go through and quite literally just start picking on the point cloud and start drawing brake lines along your point cloud using these CAD commands. And then you make sure they're selected when you go to create a surface. You select your point cloud, you make sure the line work's selected, and you go create surface. Okay. So along the brake lines, I could have drawn a brake line along the edge of the road. So, but one of the other reasons you do steep slopes is so that it hopefully grabs those. But sometimes it's nice to pick out the crown of the road manually, then you're guaranteed to have it. Or else you need to start playing with your spacing, your grid spacing. You need to make that grid spacing really small. If you don't want to do a small grid spacing, you just need to make sure you extract your center lines so that it actually picks up the crown. So there's multiple ways to skin the cat here. So it just depends on, what you want to do. All right. Go ahead and close that.
Question, as you get that other part going, how does this relate to, let's say, RTC data? That's fantastic, by the way. But with RTC data, let's say you collected a bunch of RTC data, you brought it into Register 360, manage your data edits, output an LGS file from Register 360, and then into here. It's the same process.
A little bit different process. I'm actually very glad you brought that up. That is something I wanted to cover, and I think I can do it. Here, I'll show you how to do it here. I didn't do any LGSs. I did LASs, but that's okay. I'll show you the process for that. So instead of doing a file import, dragging and dropping your data in, say you create a project, and let's say you went out and you scanned this with an RTC 360 and you published an LGS file. This also works, as we all know, with Infinity. Infinity can publish an LGS file. CloudWorks has been built into the software. It's free now. It's part of the software. So there is an Open LGS tab. So I can simply hit Open LGS. It'll browse out. You can go pick it, select your units, and press OK. The point cloud comes in. There is a button you have to remember to click, and it's this one right here, Convert to Cloud. 3DR does treat the point cloud differently than, say, CloudWorks. You do have to convert it to an actual point cloud versus the LGS file. So if you bring it in as an LGS and don't hit this Convert to Cloud, it's just going to be like an object that you can view. As soon as you convert it, it takes, I don't know, depending on the size, a minute to 5 minutes, and then it comes in great. So, but because we have CloudWorks, we do also retain all of our slicing commands, our color intensity. So this was a great addition that they added to the software, though you don't have to pay extra for it like you had to do with 3D Reshaper. Oh, does that answer your question, Rob?
Yes, but I got now that just designated another question. So CloudWorks for Civil 3D or CloudWorks for MicroStation or Revit, CloudWorks for Revit. So if you own the CloudWorks for Civil 3D, so you're doing a subscription of it, will it be included, or is everything that is included in 3DR Cloud? This is amazing that CloudWorks is in 3DR. That's fantastic. But I was just wondering how that works with.
Okay, so yeah, the licenses, they're all separate. So by buying a 3DR license, you get the CloudWorks tools within 3DR. They are not migrating into AutoCAD or anything else.
Okay, gotcha. That's perfect.
Yep. All righty. Okay, so this one I'm not going to spend a ton of time with, but this was an actual customer's live project we did years ago with a C10. So if you can imagine, trying to model this inside of Civil 3D would be an absolute nightmare, because Civil 3D doesn't like creating meshes on vertical surfaces or going underneath archways. So you'd spend your entire time basically creating new cut planes or new planes so that it can mesh this. So what we did on this particular project, we had all the data. I cleaned out the noise, just real basic. As you can see right here, we removed that tree from the face of the building. And I did that by actually going into my clean and separate, and I drew a box around the area, and I set my Z on the face of the building. So that way the Z was sticking straight out. And that way it cleaned out in essentially the X direction and removed that tree for me. So we can turn off the noise. You grab the point cloud. This time we'll go to surface modeling, and instead of creating a digital terrain model, we'll do a 3D mesh. And I like meshing in 2 steps. So essentially it'll grab the initial point cloud, it'll mesh it, and then it'll go in and it'll sample additional points and fine tune the mesh. And so you start playing with the settings here. So my average distance between points, the setting I had for this one was 0.1. And then I knew I had some gaps up at the top. So I believe I set a 3-foot spacing. And I hit preview, right? I hit OK. Went and created a mesh. And what it did, this one did take a few minutes just due to the fact that it was, there's a lot of detail here in this point cloud. So let me close out of that. And we created this mesh. There we go. I mean, still 5 minutes to create this in what in Civil 3D would have taken literally days to create. So tons of detail gets retained. And once again, I use the smoothing tools. Actually, I'm going to show you one more little thing. I think I got a hole up here. I do. One of the tools you have, so sometimes you'll get little holes in your cloud, in your mesh. So you can select it. You can say fill holes. Make sure you're in pick mode. You can go hover over the hole and press OK. Maybe, and there it goes, and it fills the hole. So just one of the little tools that's within inside of the software to make your mesh look clean. So of course I could clean that one up top. I'll do that later. I won't do that one. I'll show you that in a little bit. And the smoothing of the mesh. Just take it from raw to smooth. And it's just a little cleaner. So this once again goes out as an XML into Civil 3D or a DXF. We actually took this one as a DXF and we put it into a robotic total station, and we were able to go out and do monitoring from the surface within one of the Leica robots. And so that was an awesome use of the system to check to see if the rain and erosion was happening, because they wanted to make sure that this road was safe to still use. Essentially, that's pretty much exactly. That's what we did.
That is fantastic. That is fantastic. So you just utilized the 1 day of scan data, created this mesh, and then loaded it in for monitoring on the total station. This is the 3DR can bring in any kind of point cloud data from point clouds created from LAS, from an MS60, correct? And RTC, correct. And then the old system. Yeah. Okay. All right.
Yep. Absolutely. So yeah. So that's exactly what we used for. We created a surface out of this, and then we didn't use an MS60, even though we could have. But the inspect surface apps, or just to do like a elevation, just points deviation from the surface. And so if you had a few targets set up, great. But yeah, with the inspect surface app within any of the multi-stations, yeah, take this surface out, scan it twice a year, you'll get deviation reports right there in the field. So, yep. Okay, I guess we'll jump on to the next one. Come on, computer. There we go. All right, this is one I got to go out and do myself. Lots of fun. Come on, there we go. Okay, so let me turn on, get the full point cloud going here first. Let me jump out a little ways. Okay, so this data was done with an RTC 360. Let it catch up. Here we go. There we go. So this was an underground mine. We were like 1,400 feet underground-ish. We'll zoom in here. All right, so this is the raw point cloud. So as you can see, we've got ourselves in it. If I kind of pan around a little bit, you'll see our buggy that brought us in. You'll see our Leica robot sitting there that we are used to shooting in control. Yeah, we didn't do a very good job of running around the scanner in this one. We kind of sat still. Okay, but they wanted to be able to check this tunnel. They needed to check for, is it caving in? They also wanted to have inventory. They wanted to know where all these pipes were going, where the air vents were going. So what I did, because we were able to take the whole point cloud and essentially break it up into pipes, air vents, and we have just a clean point cloud. So everything can go on its own layer. And the way I did it, and once again, I don't know if this was the best way to do it, but this is the way I did it. Clicked on the point cloud, I went to clean, and I did a clean by distance. So I wanted the software to go out and essentially find groups of data that it thought represented the same object. So when I did group by distance, and I said, hey, what's the maximum distance between points? And I think I put in like a foot, maybe it was 2 feet. And I said, delete any points that have less than 5 points in it. So I mean, if there's like a dirt cloud or something. So that way I didn't end up with like tiny little individual point clouds. You know, and you could of course boost this up, say I don't want anything less than 100 points. You know, that wouldn't have worked with this, but I could have done 50. Essentially I pressed OK, and the software went through and actually generated 1,000 different point clouds. So this grouping became 1,000. But all the individual, essentially what it did, because the air vents were a single line, it kept all the air vents in its own line. Almost all the pipes got broken into about 5 different pieces. So I simply selected the 5 different pieces because they're all color coordinated. And I said, merge these together. So I ended up with just all the pipes on one layer. And I could follow this all the way down the point cloud. Same with the air vents. And it took me a whole 5 minutes to extract all this and put them on their own layers. There's my TS16, I forgot I'll turn that off. There we go. So we ended up with a nice, clean point cloud. All right. So there's a few little things on here. As soon as you click on it, it goes to a different color. You can change the color on how things are represented. So I liked green. I'm colorblind, guys. So green shows up really well for me. Red does not. You can also change how you view the point cloud. So right now I have it on smooth. So that's why like everything looks a little glossy. I can change that representation to flat. Now it looks more like a point cloud. And for me, it was a little harder to distinguish what I was looking at when it was like this. So that's why I really liked the smooth representation. But to each their own. But the 3D art gives you those capabilities. And then I simply grabbed the point cloud and I created a mesh. And that mesh is right here. So this is the mesh that we created. Where's the tools I'm looking for? That one right there. So I'm going to go ahead and turn on the pipes. I'm going to go ahead and turn on the air vents so you can still see them. Now we can kind of take a little tour of this tunnel. So for that mine engineer or someone that wants to say, hey, where do I got room to run that pipe? Well, this is a great way to do it. Or to cut cross sections of this surface. Once again, you can scan it, come scan it again in a month and see where things are changing. So of course the scanner couldn't see directly above the pipe. That's why we have this big hole. So this is where, once again, that filling the hole works really well. It may not be a true representation, but it does a really good job. There we go. We just filled in the top of that shaft. Nice clean tunnel. All right, does anyone have any questions about that stuff? No? All righty. We will jump into, I'm actually kind of humming right along. We might finish a little early, but that's okay with me. We're gonna go into tank inspections. Come on. Let's see here. Tank inspections, tank inspection. Here we go. Turn these off. All right. Okay, so this data is on one of Stuart's projects. So this was all done with an MS-60. So the client went out and he scanned 2 different tanks, and they want to check for roundness, verticality. You know, they want to inspect these tanks to see if they're still structurally sound. So I went in here and using the clean, separate, and the split routine, I split both point clouds so they were their own separate entities, which is what I have right here, 39 and 40. And I'm going to use tank number 40. Okay, so I can't just surface this right away because I've got this big ladder in the way. So I think the best way to do that is to clean it using that Z out command. So let's just go ahead and do it. So we go to clean and separate. Let's draw a box around it. There we go. So I've isolated that area, and I'm going to go ahead and split this. It's been split. Okay. So now I have just this area to work with. There we go. So let's click on the point cloud. Let's do a ground extraction. Let's say it's not very steep because we're essentially going to set the Z coming out of the building. Just like that. So see our Z's coming out the side of it. And I want it to create points on the ground. And we'll go ahead and hit preview. That might take it just a second. That's all right. There it goes. She's flying through. All right. So now you can see just by cleaning off the face of the building, we have a very clean point cloud. And it was that easy to just say, click here, and then click onto the face you want to send your Z out. You can also just do you can put in the numbers if you know what they are. Like I know that -1 and -1 in the X, -Y, -1 in the Y would have stuck that out. This used the system to pick it. So, all right, if you want to accept that, we press OK. I've already done so I'll just hit cancel. And I have this point cloud right here that's already been cleaned. So essentially you take the 2 and I could group them back together. So you could group your one that you isolated and the cleaned one. You just group them back together into their own single group, so they're one entity, which is what I did right here. I have a nice clean cloud. All right, so from there, you go home, or sorry, surface modeling, 3D mesh, and you create tell it to keep all points, and you tell it to create a watertight mesh. Or you can just do regular sampling. This one, it doesn't really matter. But I told it to keep all points, and I did a watertight mesh. And it ran through, took 2 or 3 minutes to do so. And I ended up with this mesh of my tank. So now I've got something to work with. If you would have had points across the top, that's fine. It would have meshed the top. There's ways to essentially remove the surface to remove the top. Okay, so let's go right into our tank inspection. So we will select our surface. We'll go to tank. This is a separate module, guys, just so you know. So when you buy 3DR, we'll cover those modules here a little later. We needed to actually create a tank. So it's going to essentially do its best job to best fit a cylinder. I know this tank is 32 feet tall. Best cylinder. Great. It's going to go ahead and just essentially create a tank, something that we can essentially compare the point cloud against. We'll press OK. There we go. We have our tank project has now started. So now we have a tank project. So I can grab my cylinder and I can say, let's create a color map. And I want it to ignore points 0.1 preview. There is our color map. We have our scale off to the right on how far things are deviating. So most of our points are falling within the 0 range, which is excellent. That's what you want. You can spin it around. Press OK. You can even go in here and attach leaders to it. It shows you your deviation at that point.
That is fantastic. How can that relate to, high rise, vertical, same kind of
We're
scenario
getting
versus
there.
a zone?
Let me go to the next one. You're going to like this.
All right.
That's actually
I'm
the next
geeking
one.
out.
All right, so I'm going to go ahead and hit cancel. All right, so we've added our labels. So now let's just check the roundness, and then we're going to check the verticality. That's kind of how we're going to close out. So we select the exact same mesh. So we have our mesh. We can now check roundness. Now for the roundness, I want to do it in 3-foot heights. So depending on how often you want to sample your data, this is where this number sets. Every 1 foot, you get a whole lot of stuff. So I did it in 3 just to show you what we're doing. And it gets its roundness based off of the best cylinder, which is the first step we did at the beginning. We had it calculate a cylinder. So it's going to base it off of that. I'm going to hit preview. All right, so here are all the different heights. I can zoom in here and you can see where it's sitting in relationship to the best fit cylinder. So this thing isn't really very round. Press OK. And, oh, wrong button. Oh well. And there you are. All your different heights, the numbers associated with them. And let's see here. Roundness, I can tell it to show only. Turn on that. Nope, wrong button. There we go. And there's your rings stacked on top of each other.
Okay, another question, just rough estimate, Peyton, just guessing. So he did this with an MS-60. What, from the time he started the field work of scanning it with an MS-60 to this product here where, an inspecting of this, let's say he went out once a month or they were concerned about this particular one, how long would it take from the field to the finish to this report, roughly? I mean,
so for an MS-60,
yeah.
So if you're going to use an MS-60, you need to make sure you are using quite dense scans. So it will take a little bit longer with an MS-60 just in regardless, but with the new MS-60, I shouldn't say it's going to take long. It's really not that bad. You need a shot to do a good tank. I would say at least every 10th by a 10th. So you need to take that into account. You know, a tenth by a tenth on a really large structure could take a little bit of time. So I'd have a hard time calculating the field work because every tank's going to be different. But from putting it into Infinity, taking out a point cloud, bringing it into 3DR, you know, that's only going to take a few minutes. I mean, you saw how quickly I created this alone. I mean, creating the surface, like I'll show you how long it takes to create the surface. It takes like no time whatsoever to generate that surface. So let me just do a show only on this. I'll take this point cloud. Oh, I want this one.
No, that answers my question. That's I just wanted kind of a rough idea of the office side. Field side could take half a day or an hour or whatever.
Yeah, depending on the tank,
Yep.
you know, a couple hours. But for generating the surfaces, it is extremely quick. 3D mesh, yeah, I tell it to create a watertight mesh. You know, I'll just go ahead and just hit preview right now and let that run. There you go. See, the surface is already done. It was that quick. It wasn't even a minute. It was a whole 10 seconds to generate that surface. So yeah, the surfacing commands inside of 3DR are just, they're fantastic. Cancel. Don't want to create that. All right, now we're gonna have you really geek out. We're gonna show you the verticality. All right, here is my tank scan. Tank, let's do a verticality test. Depending on how many samples you want to take, you set it by degree. So if you wanted to do it every 1 degree, you're gonna have a whole lot of shots. I'm gonna go every 25 degrees from the center, 25-degree increments all the way around this thing. Yes, I want it to go clockwise. I'll have it display it this way. Go ahead and just press OK. And there they are. Actually, I should have done preview first. But we've just done all the verticality. So that works with tanks. That works with vertical walls. It kind of works with everything.
Hey, Dayton.
Yeah.
Hey, what about the reporting aspect of it? Just real quickly.
The reporting?
To generate a report out.
Yep. All right. I'll be honest, Stuart, I wasn't going to go into reports, so I don't have anything pre-made.
No,
But I should have.
I was just going to say, when you go into the reporting functionality, everything that you've done and you pressed OK on, you'll be able to generate that, correct?
Yes, you can right here. So I went into report. I have a verticality report. And here it comes.
Yeah. That'll break it down so people can actually see, you know.
Yes, it will. Yep, and they can put in their own header, say this is tank. Oop. Tank 20 verticality on such and such date, put in their own logos. They can create tanks for everything, every single thing that they've done within that project. And these reports could be completely customized. Like we could spend an entire hour on just how to customize the reports. But yes, everything is here. Verticality, roundness. If they performed the task with inside of the program, they can generate a report.
Cool. That's just what I wanted to know.
Awesome.
That's very detailed.
Oh yeah, no, they've done a really good job, and they've done an excellent job in the navigating of the point cloud. It's something I can't really say enough good things about. I kind of had an issue with 3DR because it was so different from any other program, or sorry, 3D Reshaper. So by bringing it into 3DR, they give you the option of how do you want to use your mouse, and having the place where you click to rotate, you're not having to like grab the top of the screen and rotate it left and right. If you were an old 3D Reshaper user, you know, you can do that if you want to. I don't know why you ever would when you can do it this way now. But guys, that's kind of my presentation there. Let me just kind of pull up, the different modules you buy, because you do buy it by module. If you want prices, you'll have to get back to us. But let's see here. Wrong one.
As you're pulling that up, I got another question on the training or information to train on this product. I know, like with Captivate, there's training materials we've gone over. Infinity has some really good training materials. Register 360 has come a long way in the last 6 months with training materials, as well as when you start getting into these later softwares, especially Cyclone and 3DR, it's probably recommended, we always recommend you purchase either, online training, official Leica online training. Peyton can certainly do online training for 3DR or Cyclone. And then how do you feel about 3DR? I mean, I know it's early, versions are early. Register 360 is almost, it's very user-friendly. What do you think about recommending on training and moving into 3DR or as we go forward?
Yeah. So of course, I don't want to sit here and say I'm an expert at 3DR. I can create surfaces. I can essentially do what we just showed you. I can do a few other things. So if you're looking to just do ground extraction, check verticality, things like that, I feel very confident in KR's ability to train the individual. Now, if they're trying to get into, say, some more of the CAD functionality, like right here, this AEC options, where you can reverse engineer objects, where you're essentially taking a point cloud, you're modeling it, or you're, say, even doing a comparison from your point cloud to that said object. I do recommend that we do the Leica online training. There is 2-hour sessions that they offer. You can buy up to 8 hours of sessions, and that's just my 2 bits. So depending on how in depth they want to go, it's kind of tell me where, will kind of give us clues as to which direction we could send them for training. For general ground extraction, we are very capable here at KR of showing people how to do that. Absolutely.
Sure. Yeah, and that's part of the guide we're trying to provide is, you can see all these different options under the 3DR options alone. So there's a lot of information, but we can help with, we can help you with this. You can take it to a certain extent, but we always recommend almost everyone, even if they have some level of processing of point cloud data, it does not hurt, and it helps a great deal to get some of these 2-hour online trainings. I just wanted to mention that. Thanks, Peyton. This is a fantastic, I know we're getting on it, but for doing a live presentation with this 3DR, I'm geeking out here. So this is great. Thank you.
Hey, well, thank you. Looks like we got a couple questions. Let me open these up, see what we got. All right, audio's fine. Okay, well, guys, that's really all I had. Unless you have additional questions, I want to thank everyone that attended. If you need prices or anything, we'll be more than happy to get those. 3DR is only available as a yearly subscription. You cannot own it outright. So there's not really a yearly maintenance and owning it outright. No, you buy it as a yearly subscription. You can get the Pro Edition, which will give you all the options except tank. Tank is always an extra module that we add onto it. So with that, that's all I've got prepared. And I want to thank everyone for joining us this hour. And if you have any suggestions for next week, please let me, Rob Stewart, or Josh Wee know. And look forward to hearing from everybody. So thank you. Oh, got a question coming in. Couple questions. Oh, nope. All right, guys. Yeah. Let's let everybody get out of here.
Thank you, Peyton. Thank you all for joining, and we will talk soon and have a great weekend.
Thank you.
Thanks.